Hello everyone, this is Manjeet here and today we are gonna see very interesting topic which is pressure. See, pressure is what? Pressure is the amount of force applied to a specific area. So see, why am I saying amount of force is applied to a specific area? Let us understand by a simple example leaving this definition. So see, here is my green screen and right here if I keep my finger, okay, if I'm keeping my finger, so this specific area is experiencing external muscular force applied by me. So force applied on this particular area is pressure. Force applied to a specific area or unit area as written here in the definition. So simply you can understand that amount of force applied to a specific area. If I am pressing the wall like this is also an example of pressure because I am applying force on this particular area. So that is also pressure. Okay, so what is pressure? Pressure is the amount of force applied to a specific area. Now we need to understand what is proportion, and in proportion there are direct and inverse proportion. See, proportion also means variation. Proportion means variation, how two things are variation. Okay, see, for example, let's take example of your home and your school. Okay, so for example, I left my home using bus, car, auto, anything, and my objective is to reach school. So when I'm traveling, so this distance is fixed. All right, so distance is fixed. Let's suppose my car is moving the speed of 10 kilometers per hour. So at this speed, let's suppose the time will be x. All right, so when I will increase the speed, so time will be less, right? This we have read in smaller classes also, that when the speed will increase, the time will be less. So this is what known as inverse proportion. When this is increasing, then second thing is decreasing. When second thing is increasing, then the first thing is decreasing. So this is inverse, means both cannot be at the same time. If one will increase, one will obviously decrease. So this is what known as inverse proportion. This is the theory, this is the explanation of inverse proportion. Now let us see direct proportion. See, direct proportion, here you can see, as you can see here, both the arrows are pointing up. Means what? If this is increasing, then this is also increasing. So this is known as direct variation, or we can say direct proportion. So we have understood what is pressure, what is direct inverse proportion. Okay, now we need to understand how these direct and inverse proportion are related to pressure. See, I can say if I am putting my finger, so this is occupying less area on this green surface. All right, so when this is let's suppose it is occupying a space of 1 centimeter square, okay, and I am applying 5 Newton force. So what is the area of pressure? Force by area. So it will be 5 pascals. I am applying 5 pascals of force here, and now I have kept my hand. Okay, so here is my hand, the area is more. So let us assume that the area is 5 centimeters square. Now let us put it in the formula. So force is 5 Newton only. I have not increased force, I have not mentioned it. So force is 5 Newton only, but the area is increased to 5 centimeters square. So what will be the formula? Force by area. So 5 by 5, so both will be cancelled, which will be equal to 1. So what will the pressure? 1 pascals. 1 pascal. So in both the cases, what you noticed, when area is less, pressure is more. When the area is more, pressure is less. So here came the concept of inverse proportion. When area is increasing, area is decreasing, pressure is increasing. When area is increasing, pressure is decreasing. So this was the simple concept. Now how force and pressure are related. See, for example, in 1 centimeter square, I applied 5 Newton of force. Okay, 5 Newton of force I applied. So it will be obviously 5 pascals pressure. Now let's take this whole area. Okay, and now I am applying 10 Newtons of force. When I am applying 10 Newtons of force, and here will be 5 centimeter square area. So 10 by 5 is how much? It's 2 pascals. So it's obviously more than the previous observation. How? Because I increased the force. You can say pressure is directly proportional to force. So these were all understood that what is pressure, what is force, what is area, what is proportion, what is direct and inverse proportion. Now let us come to our final topic, which is force or pressure applied by, exerted by the fluids. See, what is fluids? A simplest definition I have written about fluids, you may read it. See, anything which can flow is known as fluid. Anything which can flow is known as fluid. So see, water can also flow, right? If I pour water from this glass to this glass, it is flowing. If I blow air, it is air is flowing. So both air and water are flowing. So water is what? It's liquid. Air is what? It's gas. So we can say both liquid and gases are fluids. Because why? Because they flow. So this was the what is fluids. Now how fluids exert pressure? This is the thing. See, fluids means, let us talk about liquid. Liquid is also a fluid, and when we fill a liquid in a container, let's suppose in our case this is a container, I fill it till this level with water and I make a hole at this depth. Okay, you can zoom, camera is zooming. So right here, if I make hole, so here the pressure will be more. Why? Because in liquid the pressure depends on depth. Pressure is directly variable or directly proportional to depth in the case of liquid. So as the depth will increase, the pressure will increase. With more force, water will come out. Alright, and it was all about liquid. If we talk about air, so air exerts pressure. This we cannot feel. Why? Because our body is adapted to the atmosphere, but air is applying force on us, and our body is applying counter force on air. Fluids present in our body applies counter force on atmospheric pressure, which balances all the forces, right? So this atmospheric pressure or air pressure can be understood by a simplest we can say experiment, which you can also do at home, but these stunts are little bit harmful, so do it on your own risk. So let us start the experiment. So I have done it all, and now I am going to explain what is this. So let us start with the theme. Okay, and there is a plate, and take any plate you can take. It should be flat from the middle. All right, now you need to take a lamp. You need to take it, you need to light it and fill the plate with water. Okay, so now what you need to do is take a vessel. You might be seeing, but I have also taken it the hand, you might be seeing here. Now what you need to do, you need to light the wick of this, what we can say, lamp. Now slowly you will see that in either 5, 6 or 10 seconds the oxygen will be used inside the container. See, oxygen, amount of oxygen in the container depends on the volume of the container. Kept the container on the lamp. Now lamp will use up the oxygen for burning, and as soon as the oxygen will be exhausted, so it will create low pressure area inside the container. Alright, inside the container it is gonna create low pressure. Look at the results, look carefully. See, slowly the water starts to fill up till this point. Why does that happen? That is the main objective of the experiment. See, why does it happen is very complex, not very easy. See how when oxygen used up in the container, Now it created the area of low pressure under the container. Now this container does not contain any kind of puncture, hole or anything in it. So from where will oxygen enter or air will enter inside to fill up that low pressure area? And air's property is it always flows from high pressure area to low pressure area. This we had read in class 7. So air tries to enter from the bottom, which pushes the water inside the container. By this we can conclude or demonstrate that air, so the all thing I explained you was for this activity, by this activity. So thank you very much for watching. Thank you very much.